Hi, today we are going to review what we know about ratios and how we're going to apply that when we don't know the value. So first let's talk about ratios. When we use the word ratio, we might visualize a ratio in a few ways. A ratio is a comparison of two numbers. So for example, I may compare 2/3 of something, or a format you may see it as 2:3, or the word 2, 2, 2, 3. So all of these are formats of what is a ratio. But if we're comparing two ratios and we're not sure if they're equivalent, we will know that they are equivalent or have equal value if they are the same value when simplified. Now, when we are going to compare ratios to see if they're equivalent, we have two strategies to decide, are they proportional or are they not proportional? One of the ways we've talked about this is try to find a way or a pattern when looking at their denominator. So maybe they have a same common factor or a common multiplier that we could use. So looking at 3/4, is this going to be proportional to 12/16? I'm looking at this numerator and denominator of 3/4, and I'm trying to find a pattern. Is there something I can multiply from 4 that would give me 16? Thinking about my math facts, I know that I have 4, 8, 12, 16. 4 times 4 gives me 16. I'm going to see if that works for my numerator. 3 times 4, multiplying it by that same factor, does give me 12. So this is a yes, this is proportional. Now, if I wanted to, I would take a look and try to cross multiply and compare. Looking at these two numbers, I will look at the sides and say, all right, 4 times 8, 4 times 8, that would give me 32. On the opposite, I would say 5 times 9. 5 times 9 gives me 45. Looking at these two numbers, they are not the same value, meaning that they are not proportional. This is a review and hopefully something we remember. Now, when we're finding the missing part of a proportion, we're going to use one of the methods above, but first let's take a look at a story and see how we can use our background knowledge to apply. The story is, last season Charlie lost 2 games for every 3 wins in basketball. This season Charlie won 9 games. How many games would you expect him to have lost this season based on his previous record? Well, whenever I lose a game, which Charlie lost 2 games, it does make me kind of sad. But when I win a game, like Charlie has won 3 games, it makes me happy. So I'm going to use a picture version to try to help me reflect on what I know. So right here, I'm going to have 2 sad faces for every 3 smiley faces. If I know the relationship of 2 sad faces for every 3 smiley faces, I can make this visual to help me find what I would expect for his new record. So to draw this out, I'm going to have my fraction, and with the information I know is that Charlie won 9 games. Since we talked about wins being a smiley face, I would draw 9 smiley faces. Well, there's a set of 3 smiley faces. 4, 5, 6, 7, 8, 9 smiley faces. With these 9 smiley faces, I'm trying to understand how many frowny faces I would have. Is there a pattern or grouping I can use that would show a relationship of how this works? I notice that there is a group of 3 smiley faces here. And for every 3 smiley faces, there were 2 sad. So if I find 1, 2, 3 smiley faces, I'm going to have 2 sad faces. for every 3 smiley faces. Again, another 2 sad faces. And then if you'll notice, we have one last group of 3 smiley faces, which means I have 2 sad faces. I would expect for Charlie, when he won the 9 games, his 9 wins, to have 1, 2, 3, 4, 5, 6 lost. Now, we're going to apply this with pictures, but we could also check it with numbers and just having words. We could try to find a common multiplier or denominator. So again, let's take the numbers we know. Charlie had lost 2 games every time he won 3. Now we know for this season he has won 9 games. Is there a number I can multiply or a common factor that I can say 3 times what gives me 9? 3 times 3 gives me 9. To keep this equation or this relationship balanced, I'm going to use that same value for my numerator. 2 times 3 would tell me that I have lost 6 games. That is my unknown value, and I now know the value is 6. Another way we could try this is by using our equations. When Charlie lost 2 games, we knew that he had won 3 games. However, when he won 9 games, we weren't sure how many he lost. We would use that same relationship to find this value. We would multiply 2 times 9, and that should be equal to 3 times its value. I'm going to simplify with what I know. 2 times 9 is 18, and 3 times this unknown value I'm going to use as x. What number times 3 would give me 18? If you needed to, we could draw this line so that we know that each side of this equation should be balanced. To get the coefficient 3 away from x, I would use the inverse operation of division. Since this represents multiplication, the opposite of multiplication is division. And I will also do this on the left side to keep that balanced. That cancels. X equals 18 divided by 3 is 6. Telling me, okay, the relationship here is for every 9 games won, he would have lost 6 games. Let's continue to use this and these strategies as we learn about ratios, proportions, and finding that missing value.